Hey guys, welcome to this channel that is Economics at a Glance. So guys, as you all know, we have started our production economics playlist. So here we have completed our 2 lectures. Today we will deal with our 3rd lecture, that is on factor-product, factor-factor and product-product relationship. Well, let me tell you, the management problem behind this 3 relationship is basically factor product, that is our FP. This is how much to produce, how much resource to use, and with that resource use, how much we can produce. Regarding FF, that is factor and factor. Here the management problem is how to produce. That means the product is fixed, but how we can allocate our resources, right? And the third one is P and P, that is product and product relationship. Here the management problem is what to produce. We have limited resources. Using that limited resources, what products we can produce in which amount. Okay. So, well, we will discuss all these things in briefly in this lecture. So let's get started, guys. Okay, so here I will provide you a very brief comparative idea about what is factor product, what is factor factor, and what is product product. Okay, see. So first is what is the concern? The first concern with factor product is how we can use the resource efficiently. So here it is resource use efficiency. Okay, let me tell you first. This factor product we have already covered in our microeconomics lectures. You can see in the indifference curve budget line that is same as this factor product. Okay, if you have not seen till now, you can visit to the playlist of microeconomics. There I have explained it very well. Okay, and in this lecture we will cover in details only factor factor and product product, but here just to view the comparative idea I have mentioned this all of these three. Okay, so here the concern is how we can use the resource efficiently for factor product. Regarding factor factor, our concern is the resource combination and substitution. Right, we have 2 resources, right? Using that 2 resource, we have to produce the same product. So how we can substitute and how we can combine that 2 resource, that is called factor factor relationship. Then the third one, product and product relationship. Here our concern is resource allocation. Resource allocation means we have limited resources. Okay, we have to allocate in such a way that we can have different combination of product. Okay, with one resource or with limited resource, we have to produce 2 products. So how much of each product we will produce using the same limited resources. Okay, so for factor product, how we will use the resource efficiently. Factor product, how in which ratio we have to combine the resource. And in product, how we will allocate the resource so that we can make a ratio of 2 products. Okay, from that concept the name comes factor product, factor factor and product product. Okay, next one is what are the main objectives? For factor product, the objective is how we can optimize the resource use. So optimization of resource use. Factor factor, here we are doing substitution or combination of 2 resources. Resource means what? Input. So here our objective will be cost minimization. For the input we have to expend some cost. So here our objective will be cost minimization. And product means we are producing something. After production we have to market it. So here our objective will be profit maximization. What 2 product in which ratio we will produce so that we can get maximum profit. Okay. Then next is deals with the management problem. I have already told you. Factor product is how much to produce. Factor factor is how to produce. And product is what to produce. Why? See, factor factor means how to produce. How to produce means 2 inputs you are using, how to substitute them, what ratio you will make, so that with minimum cost you can produce your fixed product. That's why how to produce. Then product means you have limited resources. Using that, you will produce two products. So in two product, what ratio you will balance so that you can get maximum profit. So here the concern is what to produce. Okay, get it? Then what are the used to determine? What are the things used to determine in factor product optimum input to use and optimum output to produce? Why? Because here factor is also there, product is also there. So how you can use the input optimally and how you can produce the output optimally. Here these things are to be used, these things are to be determined. Then in factor least cost combination. Here our objective is cost minimization. So here we have to determine what are the point of least cost combination. Well, this term I will describe in details later. But for the time being, just remember least cost combination. Why least cost? Because it is concerned with the factor. Next is for product, it is optimum combination of enterprises. How you can combine two product optimally. Why? Because our motive is to get maximum profit. Okay. Next is choice indicator. Choice indicator in factor product, our choice indicator is price ratio. Okay, price ratio. Here factor, the substitution ratio and price ratio, because we are substituting between two factors. So price ratio is constant for three of this relationship. Apart from that, substitution ratio is added in case of factor and product. Why? Because in factor we are substituting between two factors, and in product we are substituting between two products. Okay. Then in input output variables in factor product, there are single or few variable production function. But in case of factor and product, in case of factor, output is constant. Okay, your product is constant. Let's say for 100 unit, all time 100 unit. But your inputs are varied. Why? Because you are substituting between the two inputs. Sometimes input 1 will be larger, input 2 will be smaller. Sometimes input 2 will be larger, input 1 will be smaller. Okay, so the input are varied. Okay, but in case of product, the outputs are varied because you are substituting two products. Okay, so your output is varied, but your resource is constant. I have told you limited resource, so your inputs are constant and the output are varied. Then last one, explained by law of diminishing return in case of factor product. Then principle of factor substitution in case of factor and principle of product substitution in case of product. Just remember this thing, no need to mug up these concepts. Once you understand the concept, no need to remember anything. You just apply the common sense and you can get your answer. For that, you have to understand the things clearly. Okay, if you have any doubt, you can ask in the comment box as well. No problem in that. So I hope this comparative view you can get very easily. Now moving to the factor. Because factor product I have already completed in the microeconomics chapters. So today in this lecture we will deal with first factor. See, so in factor, it will help the producer manager to resolve the farm problem, that is how to produce, because we are using two resources. How we will substitute between those two input so that we can produce the product with minimum cost. That's why the problem is how to produce. Okay. So Isoquant, here the thing we which we used to perform, here it is Isoquant. What is Isoquant? Like in factor product, we were using indifference curve, budget line. Similarly, here factor we will use Isoquant. Well, what is Isoquant? See, Isoquant means equal quantity. Iso equal, quant means quantity, equal quantity, or the same amount of output. Well, what it is? The locus of points showing that different combination of the input that gives the same quantity of output. Remember, different combination of inputs that gives the same quantity of output. That's why it is also called equal product curve. Why equal product? Because your output here, it is same. Okay, your inputs are of different combination, but your output is same. That's why it is equal product curve. See, this is the isoquant, isoquant 1, isoquant 2. Okay, well, it has some properties. See, first one, isoquant slopes downward from left to right. Here, see, isoquant slopes downward from left to right, downward sloping. Yes, okay. Next is its shape of the curve, that is convex to origin. Remember, all these properties are very important. Remember, so your isoquant is convex to origin. The shape of isoquant is convex. Next is non-intersecting. If you will plot 3 to 4 isoquant, they will definitely not intersect with each other. We can't say they will always be parallel to each other, but they will not intersect, that's for sure. Okay, and the last one, isoquant placed above another, it represents higher output. See, this IQ, this is 100 units of output, and IQ1, it lies above the IQ, so its value is 200 units of output. Similarly, the IQ2, it is 300. So the one which is lying above another represents higher units of product. Well, these properties we will discuss in details in our next lecture, which will be specifically on the isoquant. But in this lecture, we will briefly cover all the concepts. Okay. So another thing you have to remember here, the slope of isoquant is always MRTS. We can note it here. MRTS is marginal rate of technical substitution. Okay, note it here. MRTS is marginal rate of technical substitution, and it is the slope of isoquant curve. Well, I have told you the curve is convex to origin, right? Well, there are some exceptions, like in case of perfect substitute. Okay, in case of perfect substitute, the curve is a straight line. Okay, you have to remember this. Like in normal way, in normal good, the isoquant is convex in nature, but for perfect substitutes, it will be a straight line, and for perfect complement, it will be L shape. Again, why it is so, we will discuss in the separate lecture for isoquant. Okay, remember, for perfect substitute, it is a straight line, and for the perfect complement, it is a L-shaped curve. Next, we will see the isocost line. Well, we have covered isoquant. Just like indifference curve and budget line relations, here isoquant and isocost line. Okay, see? Isocost line, it's a line representing various combination of two inputs that can be purchased with a given outlay of funds. That means you have a limited budget. You have 100 rupees. Okay, within that 100 rupees, how you will allocate, or sorry, how you will use the two input to produce your product. Okay, so how you will use this two, suppose capital and labor you are using for production. You have your budget 50,000 rupees. So within that 50,000 rupees, knowing the charges of capital, the charges of labor, how much you will use. So that line is called ISO cost line. It is also called price line, budget line, ISO outlay line, and it is same like isoquant, slopes downward. See here, 40 capital with 20 labor, 30 capital with 15 labor, 20 capital with 10 labor, accordingly according to the different isoquants. Okay, Q1, Q2, Q3, there are 3 isoquants. So relating to the all the isoquants, there are different isocost line. So when budget increases, isocost line shifts upward to the right. Okay, let's say your budget is 50,000 and you have calculated within that 50,000 you can afford 20 capital and 10 labor, right? Suppose your income has been increased to 1 lakh rupees. Then with that 1 lakh rupees, you can afford to expend for 30 capital and 15 labor. So when you can afford more, obviously your ISO cost line will shift upward to the right. Okay, getting the concept? Okay, so this is called your ISO cost line. Next is, and let me tell you the way we have calculated how to draw the budget line. If you have seen in microeconomics lecture, the same way is applied here to find out how to draw this ISO cost line. Okay, very similar. The concept is little bit different. There it is factor product, here it is factor factor. But the method which we have used there to find out the budget line, same will be applied here to find out the ISO cost line. Okay. Now coming to equilibrium, which is our prime focus. Okay. We have known isoquant, we have known ISO cost line. Now the thing is at which point we will produce. That will be derived by equilibrium point, right? What is equilibrium point? The point where we can get maximum profit and minimum loss. Yes or no? Or we can produce optimally. So let's see where we can get the equilibrium point. Well, see the point where the slope of isoquant, what I have told, MRTS, marginal rate of technical substitution. So the slope of isoquant will be equal to the slope of iso cost line. Okay. So let's see what are the slopes. Slope of isoquant is MRTS equal to slope of iso cost line, that will be inverse price ratio. Like usually we used to do like change in capital by change in labor. Here we will do the reverse, change in labor charges divided by change in capital charges. So not change exactly, we will do direct labor price divided by capital price. So when at the point at which MRTS, the slope of isoquant, will be equal to the slope of iso cost line, that is inverse price ratio, that point we can have the equilibrium. Okay, so that point where we can have, it will be when the iso cost line becomes tangent to the isoquant. Tangent means it will just touch the surface. See here, for the Q1, this here is the point. See, the first iso cost line, it just touches the isoquant. For the second isoquant, here is the point. For third isoquant, here is the point. So these are the point where the iso cost line just touches the surface of isoquant, or we can say iso cost line is tangent to the isoquant. Okay, that's why the name comes, it is tangent. So these are the point where we can say they are touching the surface. That means that point, both of the slope will be equal, right? That's why they are the equilibrium point. And these 3 points are called point of least cost combination. If you have remembered in the chart, I have told you in factor factor, we have to do with, or we have to go with least cost combination point. So these are the least cost combination point. Okay, got it? So here are the points where the producer should produce. Next, we will see ridge lines. Okay, see, ridge lines, basically they are boundary lines. Boundary lines means they will form a boundary to let the producer know you should work inside this boundary. You should not go out of this boundary. Okay, so what are these? See, the locus of the points where the isoquant, sorry, the locus of points of isoquant where the MPP is 0. See, these are the isoquant, convex in nature. Okay, basically if you will draw the total curve, so isoquant is oval. Okay, isoquant is oval actually, but the area where the producer is actually performing the production, if we will take that area only, so it is just like a convex to origin by nature. That's why we used to call isoquants are convex in nature, because these area we are not concerning, because in this area we are not getting any profit. That's why this border line is used. Okay, so the points where MPP will be 0, this line, this, see the this border line here, the MPP will be 0. Inside the boundary, It is a feasible region. Why? Because the MPP is having a negative slope. We know that isoquant has a negative slope. Okay. So the reason where the slope is negative, that area we should produce because it is a feasible reason. And the outside reason it is infeasible. Why? Because the slope is positive. Okay. So as the slope is positive outside, we should not produce, like a producer is not advised to produce over here. And as this slope is negative inside the region, the producer is allowed to produce over here. That's why it is called feasible region. They are unfeasible region, and the line where it is zero. The line means, see, everywhere, like suppose you will consider this first isoquant, second, third, and fourth. Every time when you go upward and upward, negative, 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 then sometime some point it will be zero, then it starts positive, right? So if we will join the every 0 point MPP, then the borderline will be arrived, and that is called our ridge line. Okay, understood? Next is expansion path. What is expansion path? See, the curve connecting the least cost combination points at various level of output. Well, let me show you. These are the least cost combination points we have discussed. If we will join this least cost combination point with origin, that is called expansion path. See, we will join this least cost combination point, it will be called expansion path. It is also called as isocline. Any rational producer always wants to produce on expansion path. If you are a rational producer, you should definitely produce on this line. Okay, get it? What is expansion path? Connecting line of all the least cost combination points. Next is our product-product relationship. So with that, our factor-factor got over. Well, we will discuss the isoquant in details in the next lecture. But for a brief introduction for today's lecture, so factor-factor got over. Today, now the product-product relationship. See, it will help the producer manager to resolve the farm problem, that is what to produce. Well, we have discussed this because we have limited resources. You have to use that limited resources to produce two products. Now the thing is how you can combine that two product to produce so that you can get maximum profit, right? So what is this? For product generally we use production possibility curve, that is the graph showing different rates of production of two goods and services. Two goods and services you are producing that an economy can produce efficiently during a specific period of time with a limited quantity of factors of production. Your factors are limited. Using that limited factor, you will produce two products. How to combine that two products? This is called production possibility frontier. And it is also called iso resource curve. Why? Because the factor is same, constant. That's why iso resource curve. There it was iso product curve in isoquant. Here it is iso resource curve. Here is your production possibility curve, that is called PPC. Here the helps the farm management, that is what to produce, also known as production possibility frontier, product transformation curve, then production possibility boundary, then iso resource curve. These are all synonyms. So I have discussed this thing, that the graph showing different rates of production of two goods and services that an economy can produce efficiently during specified period of time with a limited quantity of factors of production. The difference here is isoquant is convex in nature, but here this production possibility curve, it is concave in nature. Okay, there it was between two factor, here it is between two product. Okay. Here it is concave in nature. Remember that was convex. Even indifference curve is also convex, but only the production possibility frontier, that is concave in nature. Here just like your budget line, ISO cost line, here it is ISO revenue line. Okay. What is ISO revenue line? It shows all the possible combination of two products yielding the same revenue. Okay, what are the two combination of two products? They will revenue same. Okay, they will provide the return same. That's why they are called equal revenue line. So where we can get, okay, this is your ISO revenue line. See, different lines are there, R1, R2, R3, R4. There are different revenue lines, ISO revenue lines. Now our thing is where we can get the equilibrium. Okay, equilibrium will be attained when the slope of PPC, just like the other concepts, slope of PPC will be equal to slope of ISO revenue line. Well, just like the slope of Isoquant MRPS, here the slope of PPC will be MRPS. Noted? Marginal rate of product substitution. There it was marginal rate of technical substitution. Here it is marginal rate of product substitution. That will be equal to the inverse price ratio. Okay, where we can found it? ISO revenue line will be tangent to the PPC curve. So here we can get the equilibrium point. Okay, so here we should produce, or the producer advised to produce. So this is all about your factor and product. Of a small concept here I want to add here, that is returns to scale. This also I will explain in details, just a small view. Returns to scale is generally of three types: constant returns to scale, increasing returns to scale, and decreasing returns to scale. Well, what is the basic meaning of this? Constant returns to scale means the same inputs are required to obtain equal increment in output. Remember, when there is equal increment in output with your same input, that is constant returns to scale. In case of increasing returns to scale, less and less input, remember, less and less input are required to obtain the equal increment. Okay, here for equal increment you have to put the same input, but here for equal increment you have to put less and less input. With less and less input you have equal increment, that means it is the increasing returns to scale. Yes or no? Then last one, decreasing, more and more input you have to give to obtain the equal increment. Suppose your increment is 10 units. Okay, for 10 units increment you have to put 10 input, that is constant. For 10 increment you have to put 7 or 8 input, that's what it is increasing. For 10 units increment you have to add 11 or 12 units of input, that is called decreasing returns to scale. Okay, this is the basic thing. Again we will discuss in details how it is related to factor product relationship. We will discuss in details, just a view. Okay, and another thing is, if you have given in your exam a Cobb-Douglas production function, that is in the form y is equals to a l to the power alpha k to the power beta. This is the basic form of Cobb-Douglas production function. How you can derive what is the returns to scale here? Well, let me tell you. To find out the returns to scale, you have to add alpha plus beta, that is elasticity coefficients of the concerned factors. Like alpha is the elasticity coefficient of labor and beta is the elasticity coefficient of capital. If you will go on adding both of them, it will give rise to returns to scale. So here your alpha plus beta, if it is equals to 1, it will show you constant returns to scale. If it is greater than 1, it will be increasing returns to scale. And if it is less than 1, it will be decreasing returns to scale. This is a very like simple idea to answer the questions in a competitive exam. If it is equal to 1, constant, greater than 1, increasing, and less than 1, it will be decreasing. Well, this is the brief idea about your factor and product relationship. Next video we will come soon with our next lecture, that is completely on Isoquant. Till then, stay with my channel and don't forget to like and subscribe my channel. Thank you.